DM025 Chapter 4 Applications of Differentiation. We will start with first subtopic 4.1 Gradient, Tangent and Normal to a Curve. Below are 3 learning outcomes for subtopic 4.1. First is find the gradient of a point on a curve. Second, find the equations of a tangent to a curve at a particular point. And third, find the equations of normal to a curve at particular point. Before we start, let's take a quick view of the definitions. Gradient of a curve at any point is given by the gradient of the tangent at that point. The gradient of a curve is different at each point on the curve. While tangent to a curve is a line that touches a curve at a single point and does not cross through it. And normal to a curve at a particular point is the line through that point and perpendicular to the tangent. How to find the gradient of a point on a curve? The gradient of a curve y equals to fx at the point P. First, differentiate the equations on the curve. Second, substitute the value in point P into the differentiate equations f prime x to find the gradient. Let's discuss example 1. Find the gradient at the point with x coordinate 3 on the following curve y equals to 2x squared minus 8x plus 3. First, we need to differentiate y, so we will have dy dx equals to 4x minus 8. And then we substitute x equals to 3 into dy dx. So we will have dy dx equals to 4 times 3 minus 8, which is 4. So the gradient is equals to 4. Example 2. Find the slope to the curve y equals to x cubed minus 2x squared plus 5 at point 2, 5. First, we need to differentiate dy dx, which equals to 3x squared minus 4x. And then we substitute x equals to 2 into dy dx. So we will have dy dx equals to 3 times 2 squared minus 4 times 2, which imply 4. So the slope here is, or the gradient, equals to 4. Example 3, a curve has the equations y equals to x squared plus ax plus 4, where a is a constant. Given the slope of the curve when x equals to 2 is negative 6, find a. So we differentiate dy dx equals to 2x plus a. When we substitute x equals to 2, okay, the slope here is negative 6. So 2 times 2 plus a equals to negative 6. 4 plus a equals to negative 6. So a equals to negative 10. Please try the exercise here and refer to the answer. If you need consultations, please refer to your lecturer. Let's find out how to find the equations of a tangent to a curve. Equations of a tangent to a curve y equals to fx at the point P, x1, y1 can be found by first find the gradient of the curve y at point P, use differentiations. Refer to the previous lesson. Number 2, use y minus y1 equals to mx minus x1, where m is the gradient of a tangent and x1 is the value of x in P, x1, y1. y1 is value of y in P, x1, y1. Let's discuss example 4. Find the equations of the tangent to the curve y equals to e power 2x minus 4 at point 0, negative 2. First, we need to differentiate dy dx equals to 2e2x. And then we substitute x equals to 0 to get the slope. So we will have dy dx equals to 2e power 2 times 0, which implies 2. So gradient here is 2. Using y minus y1 equals to m x minus x1, we substitute y minus negative 2 equals to m, which is 2, and x minus 0. So we will have y plus 2 equals to 2x and y equals to 2x minus 2. So this is the equations of our tangent. Example 4b, find the equations of the tangent to the curve y equals to 4x power 5 minus 3x plus 1 at point where x equals to 1. So we find dy dx. So we will have 20x power 4 minus 3. Okay, then we substitute x equals to 1. So our slope here is 20 times 1 power 4 minus 3, which implies 17. So this is our gradient. And then we must find the point first before we continue with the equation, since we only have the values of x. So substitute x equals to 1 into y. So we will have 4 times 1 power 5 minus 3 times 1 plus 1. So this is 4 minus 3, 1. 1 plus 1 is 2. So our point is 1, 2. So we substitute into y minus y1 equals to mx minus x1. So we will have y minus 2 equals to 17x minus 1. Y equals to 17x minus 15. So this is equations of our tangent. So again, please try this exercise and check on the answer. Let's find out on how to find the equations of a normal to a curve. The equations of a normal to a curve y equals to fx at the point p x1, y1. First, find the gradient of tangent of the curve y at point P. Use differentiations and also refer to the first lesson. Number 2, find the gradient of normal. Note that gradient of normal multiplied with gradient of tangents equals to -1, where mn is gradient of normal and mt equals to gradient of tangent. Number 3, use y minus y1 equals to mn x minus x1, where x1 is the values of x in p x1 y1 and y1 values of y in p x1 y1, and mn is the gradient of the normal. Example 5. Find the equations of the normal to the curve y equals to x cubed minus 5x at x equals to 1. As usual, we need to differentiate. Dy dx equals to 3x squared minus 5. Okay, then we substitute x equals to 1. So our gradient will be 3 times 1 squared minus 5, which imply -2. So our gradient here is -2. So this is a gradient of our tangent. So from here, find out our gradient of normal, which is refer to m normal times m tangent equals to -1. So gradient normal will be 1/2. Since we only have the values of x, so we need to substitute this x equals to 1 into y to get values of y. Right, so we will have 1 minus 5 is -4. So our point is 1, -4. So use y minus y1 equals to m normal x minus x1. So y plus 4 equals to 1/2 x minus 1. So 1/2 x minus 1/2. So y equals to 1/2 x minus 9/2. So this is equations of normal. Example 5b, find the equations of the normal to the curve y equals to 6x squared plus 3 at point -1, 2. So we try to simplify y first, which is we have x squared plus 3 power 1/2. So dy dx must use power rule. So 1/2 x squared plus 3 power -1/2 multiply with 2x. So we cancel this out. So x over 6x squared plus 3. So we substitute x equals to -1. Our slope, which is dy dx, is -1/1 plus 3, which is -1/2. So that means our gradient of normal, since mn times mt equals to -1, so m normal, which is 2. Then we substitute into y minus y1 equals to m normal x minus x1. So y minus 2 equals to 2 times x plus 1. So we will have y minus 2 equals to 2x plus 2. Then y equals to 2x plus 4. So this is equation of normal. Please answer this exercise and refer to the answer that we provide. Test yourself, find the equations of tangent and normal of the curve y equals to ln x squared minus 3 at point 20. Okay, first we need to differentiate dy dx, which will be 2x over x squared minus 3. Then we substitute x equals to 2 to get gradient of tangent. 2 times 2 over 4 minus 3. So answer here is 4. Then our gradient for tangent is 4. And we substitute into y minus y1 equals to mx minus x1. Y minus 0 equals to 4x minus 2. Y equals to 4x minus 8. So this is gradient. So this is equations for tangent. Since mn times mt equals to -1, that means gradient of normal will be -1 over 4. Using y minus y1 equals to m normal x minus x1. So y minus 0 equals to -1 over 4 x minus 2. So y equals to -1 over 4x plus 1 over 2. This is equation of normal. Okay, so we're going to meet on the next subtopic, which is 4.2.